Today we talk about the indefinite integral. So for example, if I refer to an apple, I'm referring to any apple that you might see. However, if I refer to the apple, I might be referring to the apple in, say, Snow White, okay? Or the apple that started the Trojan War, things like that, okay? So this is an indefinite article. This is a definite article in English, correct? So in mathematics, we have the definite integral, and that is one that is bounded. And we learned how to evaluate the integral from a to b of f of x dx. And we took the antiderivative, and we plugged in a and b and subtracted the values. The indefinite integral does not have bounds. And we write it simply as big F of x, the integral in terms of x. And then because there could be any constant added to the end and still be an antiderivative, we write plus c. As you're wondering what that means, if I have the integral of 2x dx, what's the antiderivative of 2x? X squared. It could also be x squared minus 3, right? Either one you take the derivative of, you get 2x. So instead of writing all the different constants that we could come up with, which would be an infinite number, we just write plus c. Okay, so that's your basic learning for today. When you take antiderivatives, we should know how to check our answers. For example, this is stating that the antiderivative of negative x sine of x is equal to this. That's rather impressive. You don't know how to do that yet. This would require the chain rule or the product rule for you to take the derivative. So how do you undo the product rule? It's a little bit involved. It's called integration by parts, something that you won't learn for a while. So as we go ahead and examine this, what I want to do is I want to verify by differentiation that the formula is correct. What that means, and people get this wrong on the test, this is supposed to be give me points, folks. This means that if you take the derivative of that, what should you get? Negative x sine of x. Some people will actually take the antiderivative of that, which you don't know how to do, so you start doing voodoo math, and magically you come up with that. Okay, it's wrong. Take the derivative. If I want to take the derivative, what rule do I have to use for x cosine of x? Product. Derivative of x is times cosine of x plus x times what's the derivative of cosine? Then I have minus sine of x. What's the derivative of negative sine? Negative cosine of x. And what is the derivative of a constant? 0. So that goes away. If you notice here, I have cosine of x minus x sine of x minus cosine of x. What happens? Cosines cancel. I'm left with negative x sine of x. Is that what I have? Is that what I have in my integral? It is. So I verified that it is correct by differentiation. Next one looks a little bit trickier. Say that the integral of the square root of ax plus b dx is equal to 2 over 3a root of ax plus b to the third plus c. So I'm going to take the derivative of that. What rule will I use? The chain rule. 2 over 3a times, this will be u to the 3 halves. If it's being cubed and you're taking a square root, 3 halves, correct? So then what is u? ax plus b. Take the derivative of u. A. Because if it was 4x minus 3, the derivative would simply be 4. So the derivative of ax plus b is a. What's the derivative of this? I drop the exponent in front. This just is a constant. Drop the exponent in front, and I have a 3 halves. We'll pick up with that when we get back. Okay, here we are. We were busy taking the derivative of the right side in order to get the left side, okay? And you can see the setup here. I'm taking the derivative right now of 2 over 3a times u to the 3f's plus c. Notice that 2 over 3a is simply a constant. It will just come along for the ride. If I take the derivative of u to the 3 halves, I get 3 halves u to the 1 half. And then what is the derivative of c? Correct. So the 2's will cancel and the 3's will cancel. What's left? 1 over a times u to the 1 half times a. Now what happens? It's a over 1. A is canceled. So I get u to the 1 half, which is the square root of ax plus b. And that's what I wanted to come up with from the very beginning. You're going to have 4 problems like this in your homework. And just please note that a couple of them can be very challenging. You might have to step away from them and come back later. A lot of students don't get them right on the first try. Okay. So that's the first skill that you're going to try, is taking the derivative of the left or of the right in order to get the left. Second skills you're going to be doing is just find the general indefinite integral. X to the negative 3/7. How do I take the antiderivative of that? It'll be x to the 4/7 divided by 4/7, or multiplied by 7/4. So 7 over 4, x to the 4/7. And then you must add plus c. Why? Because it's an indefinite integral. It does not have bounds. You must add the plus c. If you forget the plus c, I take points off on the test. Yep. Scary Jackie? No, it's not negative. When I added 1 to negative 3/7, it became positive 4/7. The next one, I don't know how to undo the product rule. Okay, so I must distribute through first. The integral of 2x minus, let's see, that would be 6x squared plus 2x to the 6th dx. What is the antiderivative of 2x? X squared. What is the antiderivative of 6x squared? 2x cubed plus very good. Plus a constant. Constant all the time. Yes, the constant could be 0. But it could also be the root of pi times the natural log of 3. So, right, and I would get students who on the test, they would write that times a constant because it's still a constant, just to show that they understood that it could be any constant. So, we could discuss different ways to waste time if you want. All right, we multiply out. We got 1, negative g times 2, and then 3g times 1. I get a total of 2 plus g. Now I take the antiderivative. Antiderivative of 2. 2g. Antiderivative of g. Plus constant. What's different about letter D? We got trig. What's the antiderivative sign? It's negative cosine, right? So we got negative 2 cosine of theta What's the antiderivative of cosine? Sine. If you don't remember that, again, you'll have to remember for the test, but I've put together for you a little bit of notes. All the way on the back side, you can see that here we have derivatives. We already know all of those derivatives. What about some of our integrals? Well, you can see that the antiderivative of sine is negative cosine, the antiderivative of cosine is sine, so on and so forth. I also have some helpful trig substitutions here as well, which you're going to need to use in order to figure out how to do this one. Okay, letter E. The integral of 3 over sine squared of x minus 1. There's a substitution that I need to make. Sine squared of x plus cosine squared of x is equal to 1. I want sine squared minus 1. So if I subtract the 1, so therefore I can write this as the integral of 3 over negative cosine squared of x dx. Now what? That's it. Not sine. What's the inverse of, or the reciprocal of cosine? Secant. The integral of negative 3 secant squared of x dx. What is the antiderivative of secant squared? Tangent. So we get negative 3 tangent of x plus a constant. So sometimes doing an integral requires that you understand the relationships from trigonometry, rewriting it, so on and so forth. What's different about letter F? Sine and cosine, particularly about the sine and the cosine, you have a double angle and you have a single angle. Those are not compatible. Let's get rid of one. Any idea? Fortunately, you had trigonometry last year, at which time you memorized these formulas and then utilize them on the test. You've seen it, you may not remember it. Sine of 2x is equal to 2 sine of x cosine of x. That's how we go from a double angle to a single angle. Your double angle formulas sit right there. We make use of it. Sine of 2x can be rewritten as 2 sine of x cosine of x. That was from your chapter 7.5 test last year. It didn't go so well for everybody. Some of us have suppressed memories there. It's okay. Try to block those moments out. What do we do with what happens here? Well, the integral of 6 sine of x dx. What's the antiderivative of 6 sine? Negative 6 cosine of x plus a constant. Thank you, Jayaki. Must have a constant. Integral. So no, because we are undoing that right now. We're taking the antiderivative, so it's gone. Okay, if we get through these 4, then we don't have to do a lesson tomorrow, and you guys will have all hour to work. Okay, so we can do it. The integral from 1 to 2 of 1 minus the cubed root of x over the square root of x. Okay, Is this an indefinite integral or a definite integral? Definite, so I will actually have to evaluate it. I'm going to rewrite this as the integral from 1 to 2 of 1 over the root of x minus the cubed root of x over the square root of x dx. Just make sure you continue to write the proper notation. It's cost me some points in college. So this would be x to the negative 1/2, correct? And this is x to the 1/3 over x to the 1/2. How do I do that? X to the 1/3 over 1/2. X to the 2/6 over x to the 3/6 would make what? X to the negative 1/6, or 1 over x to the 6th, right? So if I rewrite this now, 1 to 2 of x to the negative 1/2 minus x to the negative 1. Whoop, got ahead of myself. Stop it. So x to the negative 1/2 minus x to the negative 1/6. What's the antiderivative of x to the negative 1/2? 2 roots of x. Be x to the 1/2 divided by 1/2. So 2 roots of x. Antiderivative of x to the negative 1/6. X to the 5/6 over 5/6. So multiplied by 6/5. Now, when you get these type of situations, please note that you're going to come up with a really kind of messy answer because, you know, 2 to the 5/6 power is not going to come out very nice. I'm going to trust that you can all plug that into your calculator and figure it out, right? So let's just leave that be and move on to a different example then, okay? Let's look at this one. From -3 to -1, 4y minus 3 over y squared dy. I'm going to rewrite this as -3 to -1 of 4y minus 3y to the negative 2. I encourage you to rewrite it so that you have negative exponents. Might be easier for you. If you can skip that step, then so be it. But what is the antiderivative of 4y? 2y squared. What's the antiderivative of 3y to the negative 2? 3y to the negative 1 over negative 1. So it would be plus 3 over y when we take the antiderivative. When I evaluate my integrals, I set up 2 sets of parentheses. I plug in -1, -1 squared times 2, 2, and then plus 3 over -1 be a -3. Next, I plug in -3. 9 times 2 is 18. 3 over -3 is -1. So I have -1 minus 17, -18. Uh-oh. Why is it negative? Just it's below the x-axis. That's what that means. Okay. Not too bad, huh? For letter I, is there something you could substitute for 1 plus sine squared? No, 1 minus sine squared, but not 1 plus. So we're going to be left to dividing the denominator through and hopefully come up with something we can work with. 0 to pi over 4 of 1 over sine squared of theta plus 1. If I divide each term by sine squared, that's what I get. What is 1 over sine squared? Starts with a c. Cosecant. The integral from 0 to pi over 4. Cosecant squared of theta plus 1 d theta. Do we know what the antiderivative of cosecant squared is? negative cotangent. What's the antiderivative of 1? X, or in this case, theta. Need to evaluate at pi over 4. By the way, next year when I give the Chapter 5 test we just gave, I'm going to do no calculator. Well, the first problem you can use a calculator. The rest of that they need to do by hand. Time to step it up for them, huh? All right, so we're going to plug in pi over 4. Pi over 4 is how many degrees? 45 degrees. So what coordinate, what terminal point is that? Root 2 over 2 and root of 2 over 2. So tangent is y over x. So what's the tangent of pi over 4? 1. So the cotangent would be 1. Make it negative, negative 1. Plus pi over 4. Now I have to evaluate 0. What's the terminal point at 0? Tangent is y divided by x, which is 0. So the reciprocal would be undefined. If you get an undefined value, then the fundamental theorem of calculus, part 2, does not apply. If you would consider the graph, the function is discontinuous at 0. And so, therefore, the fundamental theorem does not work. There are tricky ways that we can evaluate improper integrals, but that is not one. Last example. We'll make it. Pi over 3 to pi over 6. Cotangent is cosine of theta over sine of theta times sine of theta. What happens? Signs cancel. We have the integral from pi over 3, or pi over 6 to pi over 3 of cosine of theta, d theta. Somebody, anybody, antiderivative of cosine. Negative sine. Just positive sine. I just trusted the voice of somebody over on the side of the room. So, yep. All right, so I got to plug these values in. Pi over 3 is how many degrees? 60 degrees. What's the terminal point at 60 degrees? 1/2 and root 3 over 2. Sine the x value or the y value? Root 3 over 2 minus pi over 6 is how many degrees? 30. What's the terminal point? Root 3 over 2, yep, 1/2, very good, they change, and I get 1/2, so the root of 3 minus 1 all over 2 is the exact value of that integral. Good, you made it through all the notes, good job. Tomorrow you will have the entire hour to work on your assignment. No, you will not. No. It is a worksheet. I'm sorry, it's a book assignment. Where is it? 5.4, page 356, numbers 1 through 38, not 15 or 16. Careful with problems 3 and 4. They might give you a little bit of an issue. They can be tricky. Don't be afraid to skip a problem and come back. I would highly encourage you to not skip problems on this assignment entirely, though. Make sure you feel confident about each one. I'm not assigning you all of these problems because I just want to give you homework. I'm assigning it because if you look in years past, people needed the practice. And I want you to do well on the test. You sure can, but the directions are just a little bit odd.